Welcome to 5 steps to calculating your carbon footprint for both operators and customers of road freight transport services. In the next hour or so, you'll be given the means and knowledge to enable you to calculate the carbon footprint of the road freight services you use as a customer or as a subcontractor. Our 5 basic steps are for you whether you actually operate the vehicles or not. So now let's get started on step 1. You need to know what it is you're measuring. We say that we want to measure the carbon footprint, but what is that? It gets confusing also when, instead of carbon footprint, people refer to greenhouse gases or just simply to carbon dioxide emissions. The reason is that it's not just CO2 that gets emitted from industrial activity and transport, which has the effect of trapping in heat like a greenhouse and causing the phenomenon known as global warming. Other key culprits include methane CH4 and nitrous oxide N2O. In fact, these gases are far more potent than CO2. We all know supply chains are complicated and can raise all sorts of questions. Do you use different suppliers, in different countries, with different modes of transport? Do you share some transport services with other businesses? And what about the reverse logistics? The answer is with the simplest route, such as from material supplier to your factory, and then to one of your customers' plants. Note that we're dealing here with the road element of the end-to-end logistics chain. Once you've decided which part of the supply chain you're measuring, you can't just let the calculation take care of the rest. You'll need to do some careful thinking. The calculation will only be as good as the information fed in. Following our step-by-step process will make this as straightforward as possible. The unit of measurement is also very important. Choose one that is most suited to the loads being transported. Use more than one if necessary, and make sure to include the weight, as this is one of the most frequently requested units of measurement for many results. For example, the number of kilograms of CO2 equivalent emissions per ton of goods moved. Then you can compare the emissions from transporting feathers with that produced by transporting iron girders, because your result will be as kilograms of CO2 equivalent emissions per ton cubic meter or kilograms of CO2 equivalent emissions per kilogram cubic meter, depending on your chosen unit of measurement. Ultimately, the choice of measurement is up to you, so take time to think which measurements will allow you to get the most meaning. It's now worth learning how to use the DEC/DEFRA tables provided on the Carbon Smart website. So, first of all, go to the Carbon Smart website at the address shown here. At the bottom of the page, you'll see 3 tabs. One to select your own carbon emission conversion factors, one to see those frequently requested, and one that gives you the whole lot. Let's now click on the Fuels worksheet. You would use this when you have information on the fuel consumption of the vehicles used. We're showing only a section of it here. There are tables for various fuel types. So the calculation is as follows. The emission conversion factor, which you get from the DEC/DEFRA tables discussed in step 3, is multiplied by the total known or estimated shortest feasible distance the truck must have travelled from where it picked up the freight to the point of delivery. Therefore, let's do an example using the following information. An articulated diesel truck moving freight 100 kilometers 5 times each month. The truck is only carrying your goods and the truck is 50% full. Looking at the DEC/DEFRA tables and at the worksheet labelled Delivery Vehicles, we see the emission conversion factor for a diesel-powered, articulated truck with a 50% load is 0.9441 kilograms of CO2e per kilometre. Therefore, the calculation we use to work out the emissions for the distance we've estimated over the month is 0.9441 multiplied by 5 times 100 kilometres, which equals 472.05 kilograms of CO2 equivalent emissions.